Hello, today we're going to talk about the properties of logarithms. This corresponds to section 4.3 in our book. We're going to start off with just looking at some of the basic properties of logarithms. That's applying the product, quotient, and power properties of logarithms. This little section right here actually gives you each of those properties. The first one states for the product property that the log base b of a product is equal to the sum of the logs of each of the individual parts of the product. So with the product property, we're actually looking at product translating into a sum. With the quotient property, we have that the log base b of the quotient of x and y is going to be equal to the log base b of x minus the log base b of y. So the quotient property turns this quotient here into the difference of those two logarithms. And then lastly, we have the power property. The power property states that log base b of x to the p power is going to be equal to p log base b of x. Okay, so what that means is that I think of this as the exponent gets kicked out to be multiplied by the logarithm. Okay, so that's not necessarily maybe the most mathematical way to explain it, but that's always how I think of it. This kind of reminds me, going back to your laws of exponents, how the product property with laws of exponents, you added the exponents. With the quotient property of exponents, you subtracted the exponents, and then for the power property with exponents, you multiply. And so I think of that here. I think of this one, you end up with a sum. This one, you end up with a difference. And this one, you end up multiplying the logarithm by that p exponent. Okay, so we're going to use the product property of logarithms to write each logarithm as a sum. And then we're going to simplify if possible. The simplification is going to come from the properties that we saw in section 4.2, the very basic ones. So thinking about this first one, we have log of 2xy. So 2xy is 2 times x times y. So we're going to use the product property to rewrite this as log of 2 plus log of x plus log of y. Now remember, because it has a log with no base, we're in our base is 10. None of these can be simplified out of base 10, so that one is complete. For number 2, we have log base 2 of 2xy. So those look very similar, but we're talking about different bases. So when I rewrite this one, number 2, I'm going to get log base 2 of 2 plus log base 2 of x plus log base 2 of y. Now, log base 2 of 2, 2 to what exponent gives me 2? Or the number itself, this is one of our basic log properties, so this can actually simplify to be 1. Okay, so I end up having 1 plus log base 2 of x plus log base 2 of y. And that is fully simplified. For this last example, we have the natural log of 3 times a plus b. When we do this one, we're going to end up with the natural log of 3 plus the natural log of a plus b. I cannot separate this one because that is not a product, that is a sum. The only product here was 3 times this entire sum. So when I separate it out, this is as simplified as it can get. Okay, so for the next part, we are going to take a look at using the quotient property to rewrite these logarithms as a difference and then simplify if possible. So for this first one, number 4, we're going to do log base 7 of z divided by 49. So we get log base 7 of z minus log base 7 of 49. But 7 to the second power equals 49. So 7 to what power is 49? This can be simplified into just being a 2. So we end up getting that log 7, base 7 of z minus 2, and that is simplified. For the next one, number 5, we have log base 7 of a divided by 14. it's going to give us log base 7 of a minus log base 7 of 14. Now this one is not a nice, easy exponent of 7, so I cannot simplify that one. This next one, though, for number 6, we end up getting log base 10 is assumed of 100 divided by x plus y. So I'm going to end up having log of 100 minus log of x plus y. Remember, that cannot be separated. So this term right here is good. This term right here, though, that I'm underlining in green, can actually be simplified because the base here is assumed to be 10. 10 to what power is 100? That's going to be 2. So this just simplifies down to 2, and I bring down that other term. Okay. So the last ones we're going to do here is going to be applying the power property of logarithms. That's using the natural logs in the first two. So natural log of x to the 5th, that just kicks that exponent to the front. So we get 5 natural log of x. Second one, we get natural log of e to the 5th. So that's going to be 5, the natural log of e. E to what power is equal to e? Well, that's going to be the first power. So this is just the same thing as 1. 5 times 1 is just 5. So this is your answer for number 8, fully simplified. And then the last one, it looks like a tricky one. If you think about this radical expression with the cubic root of x to the 2nd power, I can rewrite that as log of x to the 2/3. Okay, remember, because if I have this, that's equal to having x to the 1/3, but if the x inside is squared, it's going to be 2 times that, so that's going to be 2/3. So I just pull that 2/3 out. It's the power property, and I'll be left with 2/3 log of x. On these next 3 examples, we're actually going to expand each of these. Now notice that they all involve not only products, but also quotients, and some of them actually, like number 12, include exponents or powers as well. So this is going to show a combination of all the different properties combined. So if I'm going to expand this first one, we end up having log base 3 of 5z over w. So we have the product of 5 and z, and then we have the quotient with w. So if I'm going to expand that out, I'm going to take the numerator, log base 3 of 5, plus log base 3 of z, that's for my numerator, and then to identify that that quotient with w is happening, I'm going to then subtract and find the difference with log base 3 of w. So that is fully expanded all the way out. Now sometimes people like to put parentheses here. In this case, it would not be necessary because we would follow our order of operations. We would add those together first before subtracting, because we do addition and subtraction from left to right. So we would get that product together. So you don't necessarily need the parentheses, but sometimes you might need the parentheses, and we'll see some examples of that as well. Number 11, we have log base 7 of AC over 5D. Again, we have a product and a quotient. We actually have 2 products. There's a product in the numerator and a product in the denominator. And then there's the quotient between those things. So for the numerator, we're going to end up getting log base 7 of A plus log base 7 of C. And then for the quotient, we're going to have log base 7 of 5 plus log base 7 of D. Okay, now in this case, again, you don't necessarily need to put parentheses around it. It makes me happy to do this. I like to have the parentheses around at least that quotient part, but I believe that your homework does not require it. But if you are getting wrong answers, go back and look at and potentially put in parentheses that might be missing. Okay, for this last one, we have the natural log of x to the 2nd power times y. So we have the product of those 2 things, and we also have the power. So for the first term, I'm going to have the natural log of x, but that squared gets pulled out to the front, so it's going to be 2 the natural log of x. And then because it's the product between x squared and y, we then sum the natural log of y to our first term. For the next one, this one's a complex one. We have the natural log of the cubic root of x squared over w plus z. So we're dealing with the power rule with the numerator and then the quotient rule. Now remember, in the denominator, w plus z is together combined, so that is actually not going to get split up. So we end up getting 2/3 the natural log of x minus the natural log of w plus z, and that would need to go in parentheses. For the last one, number 14, right here, we have log base 2 of the square root. Now, the square root is covering the entire thing, the numerator and the denominator, of 4x divided by y z to the third. So we have product, we have quotient, we have powers, and we have fractional powers. So first thing I'm going to do is I'm going to pull out a 1/2, because this square root is equal to a power of 1/2 on this entire thing. So I could rewrite it as 4x y z to the third all to the 1/2. So I can pull that 1/2 out because it's a log problem. Then in the numerator, now I'm going to put this in parentheses because that 1/2 gets applied to all of these things. So I'm going to end up having log base 2 of 4 plus log base 2 of x minus log base 2 of y plus 3 log base 2 of z. Now again, you might want to put a special little, I'm going to put them in red, special little parentheses around these in the denominator. Again, they might not be necessary, but I kind of like to make sure that I group things in the denominator together. Again, it might not be necessary. I'm going to say that like 3 million times, but that's how I like to represent them. Now, this 1/2 would be distributed to all of the terms within there, so we stay true to the original problem. Please make sure to watch part 2, where we go over the change of base formula, other examples of condensing logarithmic expressions, and we'll also look at some tricky examples from the homework.